Remember?
So yeah.
What kind of graph? Who?
Yeah.
First graph is what? First graph is a nice straight line. Second graph, quadratic. To the origin, right? Turning point is to the origin. What does this look like? Right, so it's yeah, inflection point that could work. Something like that, right? What does 1 and x look like? When it's more than 0 and when it's less than 0, it looks two different. Well, it looks similar, right? More than 0, it looks this way, not straight. Hold on, eh? Right? Sketch them down and then head up transformation. So we're gonna look how to transform all of these. All right? Head up transformation.
No, I don't realize I was looking for that. Yeah, don't think about it. No.
Y'all done? Right, head up transformation. Right, so
I see it. Was it? Yeah, yes. Somebody, you were Mr. Ramna class. I saw somebody pop in it.
Might as well do that. All of that, narrow and free. Yeah, no long ways, long gonna be to have a ceremony where they bring all the cup, one cup. 25, 6 years. All right, so here we have some transformations that we have to all write out. As I said, if you all had print the top, if you all had print the workbook, you all would have gotten all of this, right? The workbook on the LMS. Something you don't use, right? Under module 1, have a workbook 1. You can have print it, you'll get all of this. But don't worry with that, right? Right. Huh? Yeah, write it. I don't have it, so you have to write it. Right. So we're doing the transformations of all. So if I give you f of x, right? And I add a to f of x, what would come to the graph? Let's use this one. If I add 4 to this graph, what would happen? Add 4. That will make all the y values larger by how much? So what does plus a do? Shift the whole graph upwards 4. Right? Upwards e. You okay with that? What would minus a do? Minus on the outside will do what? It will drop the graph down. So if it's minus 4, it will bring the graph down 4. That's okay? Write that down. If we have f of x, then if we have f of x, right? First one, f of x plus a, f of x plus a on the outside. F of x plus a is an upward shift. F of x plus a is an upward shift. F of x minus a is a downward shift. Right? Write down all 9 transformations now. And then we'll go through each one. Wait, 2 missing. Anyway, I'll give you after. 2 missing. What is f of x plus e now? F of open bracket x plus e. What would that be? Shift where? Shift to the, whenever it's a plus, you're shifting to the left. Whenever it's a minus, you're shifting to the right. Okay, but let's write them all 9. It's really 10, but I will clean that now. Right, so as I said, f of x plus e, both in brackets is shifting to the left. And I have one missing, the one that's missing we did it last. That last. Ready? Number 3. So number 3 is a shift to the left. Number 3 is shift to the left. Number 4, shift to the right. Number 3, shift to the left, E. Number 4, shift to the right, E. Right, so we did all these already, right? What about an A in front of the X? Right, whenever there's an A in front of the X, that's a horizontal stretch by a factor. It's a horizontal stretch by a factor of 1 on E. right? So if there's an A in front, sorry. Yes, if there's an A in front. If there's an A in front of the X, that's a horizontal stretch by a factor of A. Right? So there's A in front of the X, horizontal stretch by a factor of 1 on A. If there's an A in front of the f of X, it's a vertical stretch by a factor of A. If there's a minus, what does the minus in front of the whole function do? It's a reflection in the x-axis. If there's a minus in front of the x, it's a reflection in the y-axis. And last one in this set, whenever they ask you to find the inverse of a function is the reflection in the line y equals 10. Okay? Those are the 9 that you have to know, and one more from last week. Number 10, anybody remember it? Modulus. Last week we did modulus, and modulus is what? You reflect the what? You reflect the part below the x-axis in the orbit. Okay? So number 9, number 10 is the modulus of f of x. Number 10 is the modulus of f of x. Who is it? Oh,
Yes.
right, sorry. Last one is modulus of f of x. A reflection, you can write this down. It's a reflection. Last one, number 10. Modulus of f of x. That's only 2 lines. Well, you just have to up there, man. Look it up there. Number 10. Modulus of f of x is a reflection of the negative part in the x-axis. Only the negative part, right? It's a reflection of the negative part in the x-axis. Have you cleared up? Now to apply this. Let's start easy. So we will focus on graph number 2 and graph number 4. Right? Those are the 2 most important graphs. 2 and 4. So let's try a simple example here. What are the 2 transformations happening here? What are the 2 transformations happening here to this graph? That was the original thing, right? That was the original graph up there. And this is the new one that we're going to draw. What it says? Upward. So the first shift will be upward 4. And the second shift is 2 to the right. That's okay? So if I wanted to show this graph, right? Upward 4 to the right 2. What's the most important point I should have? I should have the minimum point. So the minimum point is 2 to the right, 4 upwards. So the minimum point is now 2, 4. The minimum point is now 2, 4.
Very well.
You okay with that? So within a question, you have to identify the shifts. All right. So the first shift here, it went two to the right, then it went 4 points. It don't matter the order, right? You can shift here and then here. It's up to you. All right. Let's shift. Let's do one more the same thing. Any questions, Olia? So you have to learn your shifts, right? Let us do our next one. Any questions online? Right. So your first shift, 2 to the right, 4 points. You have to be able to highlight on your graph because remember it's a sketch. It's not an actual plot, right? You have to identify on your graph how you're showing these things. So since here was 0, 0, the easiest thing to show the shift on will be the turning point. That's okay? Try this one for a minute. Let me change it up a little bit. Let me put a 5 here. Let me put a minus here. And x plus 4 here. Try that. Yeah, but you can see why it's the minimum point as well. So instead of having to go and find a chance to do the C of it. Try number 2. Apply the shifts to number 2. Pay attention to the minus sign. Try quick. Pay attention to the minus sign. See what the minus in front does. So sometimes I like to rearrange it, right? Sometimes I like to rearrange it like this. Right? Sometimes I like to rearrange it. What I was saying, right? I like to rearrange it, right? So I'll put minus x plus 4 squared plus 5. So you have 3 shifts there. See if you're seeing them, right? 3 shifts. Are you ready? Ready? So first thing I recognize here is that I am this is a reflection in the x-axis. So I saw the minus sign and I recognize a reflection in the x-axis. Second thing is I recognize that it's a shift to the left 4 and positive means upward 5. Right? Reflection in the x. So this whole thing's coming down here. Then it going up 5, then to the right 4. Right? What I'm going to do differently here is I'm going to do each stage. Right? And I'm going to do it in one graph, right? So your first stage is this. I'm going to reflect in the x-axis, so it becomes this. That's stage one. Then stage two, I am going to move it to the left 4. So I'm moving this to the left 4. 1, 2, 3, 4. And it becomes minus 4, 0. Now, last stage is what? Last stage is I'm moving it up 5. So we move it up 5. So it will look something like this. So I got minus 4, 5. Anybody got up? All 3 stages? Right? Don't forget, right? So reflection in the X, that was stage 1. Stage 2. Stage 2 was to the left 4. So I move it to the left 4, and then stage 3 up 5. That okay with that? Any questions? Right? So let's go on the graph that you will see more in your exam, number 4. Number 4 is the graph Keshav that you might see in your exam a little bit more. Ready? So something important, 2 things important about this graph. Any questions here? Are you okay? This graph here has 2 important things. It does not exist, right? It doesn't exist like if we call them quadrants, 1, 2, 3, 4. It doesn't exist in the 3rd quadrant and the 4th quadrant. It only exists in the 1st and the 3rd. Sorry, it doesn't exist in the 2nd and the 4th. It exists in the 1st and the 3rd. That's okay? Next thing, you will recognize that the graph never touches the axes. Right? These axes are called what? Asymptotes. Right? They are called asymptotes. Here, the x-axis and the y-axis. Right? So the asymptotes move with the function. So if I shift this function to the left, the asymptotes have to move as well. If I shift it down, the asymptotes have to move as well. Are you okay with that? Right. I didn't do an example here with a vertical stretch, right? The reason why is just you're not really going to see it much on the graph, right? The main shift you will see is the one I showed you. So let's take a look at a couple of shifts on this one, right? Let's try number 3. Y is equal to 1 over x plus 2 minus 3. What did I do to the original graph? Plus 2 means I'm shifting it to the left, 2 pluses to the left, and minus means I'm shifting it downwards. That's okay? So I'm shifting this graph to the left 2 times and down 3 times. All right? So the first thing before you start to draw a graph, you need to do your asymptotes. Right? So your graph shift down 3. So minus 3 is your new asymptote. So it's shifting down 3. 1, 2, 3. So your new asymptote is this line. What's the equation of that line? What is this? Y is minus 3. Just so. Y is minus 3, right? So the asymptote is Y is minus 3. Right. Y is minus 3, right? So horizontal lines, the equations are y is equal to whatever point it's passing through. Vertical lines are what? X is equal to whatever point it's passing through, right? Nice. So we move into the left, 2. So the asymptote will be x is equal to minus 2. How will the graph look? Here and here. Everybody okay with that? So it looks like that. Easy, right? Copy it down. Try one from us.
Well, like the man, right?
Try that, yeah?
So you see the feeling of video why you should do it. So it's not like 4 people lessons. We got the video after the product. Say something in WhatsApp. I feel.
You see.
Yeah, it might be on the show. It's a
Try number 4. Try number 4.
I'll make it. She didn't even care the question. Supposed to be.
Okay, first one. Coalition. Right? I will do all four. I will do all three arm shift, right? Right. I will show you all three shifts. Right, so the first thing I will do is rearrange it. And then look for my shifts. I have a reflection in the x-axis. Right, sorry, reflection in the x-axis. We go in to the right 3, upwards 4. All right, so I'm doing them one by one. I am starting from here. And then I'm going and reflect. I didn't give you a modulus. That's a good idea. I'll give you a modulus after. First one, we're going to reflect in the x-axis. So if I reflect in the x, here will come here. And then here will come here. Right? Then we shift in to the right 3. To the right 3. So that will be x is equal to 3. And then last stage, we're going to shift it. Last stage, we are going to shift it upwards 4. So we have it here. And we have it here. Right, so I have it here and here. That's the final answer. All right. Let's change my markers. I have one more problem here for you. This came in 2019. How you going to sketch that? Huh? Find a way to split it up, right? How we can do that? Partial. What else? How can we break this up? Because this is not looking like what we've been doing all the time. How could I turn this into this? Any answers online? Yeah, sure. Long divide. Long divide. If you long divide this, it will look like this. Go ahead. Huh? No choice. Yeah, what you could do is you could plug in all the x values, positive and negative, find the y, and then sum. Hurry up, long divide. I'm gonna get a mark.
It's like no fraction. I think I have to give it up. Because it's a single. So we can just write it Yeah, I got it now. Yeah, that's one guy. Access on was minus over x or I don't see minus by x is 0. Bring on 0. Minus that.
Alright, I'm gonna show out the long divide. It's got a car long divide. Do that. The remainder will be this. The answer, the value answer, here, and that's the remainder. Right, how to long divide? Right, x into 3 x's, 3 by x's, 3 by minus 2. This is 0, this is 1. Right? That's it? Huh? X into 3 x's, 3 by x's, 3 by minus 2. Minus 0, 1. So your final answer is 3 plus 1 over x minus 2. That's all. And you're done. Catch it now? You're done? There's 4 here. Well, no. 1 year come kind of tricky where you had to perform a reflection. But I found it was hard to reflect, so I just redo the whole graph. So they asked it to reflect at the same. They asked you to find the inverse, which is a reflection. And it was easier to redraw the graph and then do the inverse. I find the inverse and then redraw the graph. Than to try to, I had trouble reflecting this. Right, so and that was my problem. But basically you take points and you switch. So if the point is 2, 3, it becomes 3, 2. Like 5, 4. And I find out taking it kind of long. So I just took the function they give you, find the inverse and sketch it over. So it was more accurate.
Yeah.
But they want to use it as big points and reflect. Right, so it should be done here. This is 3 upwards. And this is 2 to the right. That's okay? Very important to kill when it comes to functions and things, right? So, oh, why I do that? Yeah, that's why I just talk about. This here is going 3 upwards, right? So it now becomes y is 3. This says 2 to the right. Minus, which is right next to the x, is to the right. So to the right, right? Same position. Yeah? Right, just suppose, right? Because I'm asking you now. So no supposing actually. If this h was to find the modulus of this, what would you do? What would you do if I asked for the modulus of it? Reflect the part below the, how you reflecting that? Right, so it might look something like that. Something like that, right? Only the part that is what? Only the part that's below the x-axis is reflected up there. Yeah, kind of lame, but that's what I wanted to show you. Okay, so you reflect the part below the x-axis above. Right? For example here, Modulus will be to reflect this up here. So it will look like this. Are you okay with that?
Yes, sir.
All right. Now that we can sketch head up functions.
Sir,
Functions.
eu quero isso.
Can he walk around through that?
Just put in drama, just in drama.
But he walk around.
Yeah. Yeah, we still something. We still something.
Right, head up functions. So in functions, we're going over all the little definitions and all the things that you can look up by book, right?
You know, you play football, but yeah, like. Football,
Let's do cricket.
the black guy looks at yours.
You what?
The black guy looks. DDX. Yes. DDX 1990. Actually, over here, that was just.
All right, so let's take a look at functions. Right, what you all remember about functions? You might remember a set of x values that we map into a set of y values, right? What do we call these values here? We call these your domain. What do you call these values here? Not yet. So if we have A, B, C, right? D, E, F. We call these values your codomain. Right? So we call these values a codomain. If each of these values have a mapping from the domain, then we call them the range. Right? And we only call them the range since all the values have mappings, right? Yeah, have the arrow thing, right? So because each of these have a arrow going to them, we call it the range, right? But for now, we call all these values in here your codomain. Everybody okay with that? Yeah. What type of mapping is this though? Right. So we have different types of mappings. So I'm gonna draw 4 and tell me if you can name all 4. So we have 4 types of mappings here. What's the first one? The first is a 1-to-1, right? What about the second one? 1 to many values going to 1 value. You're saying that? Well, that's 1, but many values, that's 2 going to 1. So this is called a many to 1. You okay with that? What about C? What's it good? Be careful with C. What's C carefully? 1 to many. 1 to many. You're seeing that? And many going to 1. So it's a what? So it's a many to many. That's okay? Many to many. This one is a what? 1 to many. 1 value going to many. So those are your 4 different types of mappings. For the into cool term, all right? Actually, all in the back, in the middle. Go ahead. Copy them down.
Serious. Actually, we know by stories.
Ready? Anybody remember how functions are defined? Functions could be only 2 of these. Which ones? Functions could only be 1-to-1 and underneath this, make a small note. A function is a relation in which A function is a relation in which no two or more ordered pairs in which no two or more ordered pairs have the same first element. Right? So then look here, right? Nothing, no ordered pair. By the way, I forgot to remind you what is ordered pairs. Ordered pairs for this one, right? Is A, D, B, E, C, F. You'll recognize that none of these ordered pairs have the same, none of these ordered pairs have the same body from it to domain in it. See that? Look at the ordered pairs here for this one. This is the ordered pairs for A. Look at the ordered pairs for B. A and D, B and D, C and F. Right? See that? None of the ordered pairs have the same what? Right? They don't have the first element in it, right? But look at these here. This have what? This ordered pair of B, E, and BF. Right? So what that means is that only a one-to-one and a many-to-one functions are, sorry, only a one-to-one and a many-to-one mappings are functions. So the only functions are one-to-one and many-to-one. These are not functions, right? These are not functions. So you can't have A going to D and E. You can't have B going to E and F. Those are not functions. Everybody okay with that? Right? There's also a small test if we have a graph. The vertical line underneath this, the vertical line test. The vertical line test. The vertical line test can be used to determine if a vertical line test can be used to determine a vertical line test can be used to determine if a relation is a function or not. First up, vertical line test. I'll show you an example now. First up, for it to be a function, the line must be, sorry, the vertical line must cut the graph at how many points? 1 point. The vertical line must cut the graph at 1 point. Only. 1 point only. That's okay? So if I give you a function like this, and I said, Dante, is this a function? I give you this graph. What do? Draw vertical line. So draw a vertical line. If the vertical line cuts the function more than once, here it cuts it twice. Then it's a what? This is not a function. Are you okay with that? Adam? So if the vertical line cuts the function more than once, it is not a function. You okay with that? Keshav? Yeah. What type of mapping is this? What type of mapping is this function? 1x value to many, right? 1x value is here, and you're getting 2y values. One here and one here. So you're getting 2y values. Therefore, it's a 1 to many, which is not a function. Everybody okay with that? Online, any questions? Online, all okay?
Yeah.
Right, so the main thing we're doing today is we're introducing all these things about functions, right? All right, nice. What are the two important things that we need to know about functions as well? We need to know two more important, well, three things, but two important things to help us figure out the two. If the function is what? Right? If the function is injective and if the function is surjective. All right? So you need to know if the function is 1-to-1 and if the function is 1-to. If those two things happen, the function is said to be bijective. All right? Let's at least do this one today. All right? Next subheading, to determine if a function is 1-to-1. Anybody remember that? Wait, can I not master it right? No, surjective means onto. Surjective means onto. It means that it all the values in the codomain and the range is the same thing. But so there are times, watch here. The codomain and the range is not the same. This value in the codomain, but not the. So this function is not. So I can't find the inverse. I can find the inverse. Next. Right, next subheading, injective. Next subheading, injective. Right, or we call this 1-to-1. How do we determine if a function is 1-to-1? So to determine if a function is injective, here's what we do. We have two methods. Method one, we do instead of a vertical, we do a horizontal line test. Right? We do a horizontal line test and it should only cut once. Okay? Right? It should only cut once. Only cut. Second method, we call this method the mathematical method, right? If f of a is equal to f of b, then a should be equal to b. You can show this mathematically, then 1-to-1. Or if you just sketch it and show this, then it's 1-to-1. All right. Let's try one example before we wrap up, right? After functions, all left in module 1 is cubic equation. And that's the end of module 1. Right, we have classes all of November, and I will give you the time till December, right? Between now and December, you want to complete tricks and a little piece of module 2. Trick is the main part of module 2. We want to spend the whole holidays on tricks. But there one in here, what? All right. So we're gonna do both methods because y'all can catch real good now, right? Let's go. Method 1. I'll just catch this. Let me go with Adam. Yeah, Adam. Adam, catch this real fast. Adam, any sketches?
Oh yeah.
X squared plus 1 is what? And 1 up, right? So it will look something like this. Why that wrong, Joseph? Why it wrong? Something on it wrong, yeah? No, it went up 1. What's this here? What does this say? X is all the positive integers. So should the graph exist on this side? No. So that is a graph. If I do the horizontal line test, will it pass? Yes. Right? So therefore, 1 to 1. And 1 to 1 because it passed the horizontal line test, cuts once. Right, Lucas? Lucas, I want to help here. I want a little help with method 2. Method 2 says that f of A is equal to f of B. What does that mean? Yeah, time up? No. So that's choose any two. Plugging A in there is a general thing, right? Plugging A in there and plugging P in there. The ones will cancel and you'll get A squared is equal to B squared. What are you gonna do now? Carry across the squared and it becomes the square root of B squared. So the answer A is equal to B. But remember, when you square root P squared, right? And you will normally get plus or minus. But why do I ignore the minus? Because of the range. So the answer is A is equal to B, therefore 1 to 1. Nice, got choose bad. If you choose bad, you gotta be exhaustive and choose all. Huh? It will work for you to show all the values. So it's not a good proof now. It's not a complete proof. Okay, copy it down. Copy it down and we can probably Yeah, we will stop there.